Our first speaker, Vamsi Krishna Hari from India. Today we'll present a topic related to what is AIOPS and how it works. You know, when we're speaking about SRE, for example, site reliability engineering, or totally about some production, we have to set up monitoring, observability, and sometimes it's very, very terrible situation when you have to create it manually, support it, and react on any problems. And sometimes you see it like, so we have ML, we have AI, artificial intelligence. Why we don't not implement it in our reality, in our monitoring solution? And seems that like Vamsi Krishna today will share his experience, share how to set up it, how to work with AI ops, and what is it exactly. So guys, let me introduce Vamsi Krishna Hari. And before we start, guys, you can ask your question. Please don't hesitate to do it. And one more important point, like if you ask question, please write your email, for example, or some identical, how we will identify you in the future, because like Vamsi Krishna will select the best question. I know, maybe the most interesting, maybe the most difficult for you, Vamsi Krishna, yeah, and you will win. And then we need this contact just to contact with you, to share and send you the prize, like a book, yeah, and just click on the Q&A session, write your question, and don't forget that if you don't put your like a name or email or I don't know, maybe some another idea how we can contact after that, it will be very difficult to find you. So without further ado, Vamsi Krishna, please go ahead, share your screen, and let's start your presentation. Sorry, you want to just drink, but anyway, you are muted. Please unmute yourself.
Okay.
Yeah.
Thanks, Victor. Thanks for handing over. Are you guys able to see my screen?
Yeah.
Okay. Thank you. Okay. So first of all, my name is Vamsi Krishna Hari, and I'm part of Cloud and DeVops India practice team, and I've been part of EPAM since 3.5 years. And today my talk is about what is AIOPS and how it works. So the implementation part of it, and the agenda pretty much covers the AIOPS and the solutions that it provides for the IT operations challenges, and what are the KPIs for measuring the success of an AIOPS implementation, and the architecture blueprint, which represents the different layers of the AIOPS architecture and how it can be implemented, and a reference solution or a reference architecture for AIOPS using the open source tools, and AIOPS use cases. Try to cover some of the use cases for AIOPS and with the workflows added to them, and high-level implementation roadmap, and finally the implementation challenges, some of the implementation challenges that I'm aware of. So talking about the AIOPS definition part, AIOPS is a combination of the automation, the machine learning, and the analytics, and to put a process to wrap around it and to enhance the IT operations. And there are multiple practices which are already there in the IT operations world, which are done in silos. AIOPS is also trying to put a wrap around it and adding some intelligence on top of it, so that we enhance doing the things that we're doing right now. And the definition standpoint, it stands for artificial intelligence in operations. That itself defines the functionality of the AIOPS, and it was first introduced in 2017 in Gartner's post. And before talking more about AIOPS, like probably we can talk a little bit about the challenges that are there in the IT operations world. I mean, I'm sure like there are tons of challenges, but these are some of the subset of the challenges that I try to represent over here. So with these latest with the recent improvement in the monitoring tools and the observability and the traceability platform, we have a lot of monitoring data that we get, and obviously a lot of data means a lot of alerts, and a lot of the noise caused due to these alerts. And sometimes these could be the false alarms, and there would be an unnecessary chaos due to these false alarms. So that is that is one of the challenge, and the collaboration, in the complex, in the hybrid systems, where there are multiple components which are dependent on each other component, and the dependency relations are complex. It would be hard for a person to manually correlate between the different events in a system and then try to find the RCA, right? So the collaboration part of it, and majorly there are tools which are working in silos. I mean, we have different tools for different purpose, and they are not unified in one way, and so it's a challenge to collaborate all these things. And similarly, the correlation part of it, when we talk about the the hybrid systems, where there will be multiple events in the multiple components and multiple places in the system, and it becomes hard to correlate these events because of the because of the complexity of the systems. And most of the times the ops, in ops, like 60% we are 60 to 70% we are always reactive to the incidents. I mean, instead of being proactive, we are always reactive. So the lack of the predictability in the systems is another challenge that AIOPS is going to address. And I think 80% we're trying to do the repetitive and redundant tasks. Most of our colleagues in the IT operations will be agreeing with this. Like we have a KB, and we'll be having a rule of actions that need to be followed in case of certain issues, and that will be followed most of the time. So they are repetitive and redundant, and it takes a lot of time to kind of resolve the issues in that manner. That is another challenge. And finally, the lack of continuous improvement and optimization in the system. Because of this manual efforts we put in the operations world, there is less room for the continuous improvement of the system, wherein the optimization of the resources and continuous improvement of the process. This will not be in a gradual manner. It will be once in a while. So that is another challenge in the IT ops world. So this slide talks about some of the solutions that AIOPS provides to overcome these challenges. So when we talk about the event correlation challenge, this can be handled with the topology mapping diagrams and the event correlation dashboards. So usually some of the monitoring tools provides the network topology mapping diagrams, but we can enhance these things and build the topology mapping diagrams using AIOPS, which are dynamic. So we usually have the topology mapping diagrams, something like this. I just referred this from the app dynamics, but these are one example of the topology mapping diagram where the relationship between the different components in the system is mapped. So instead of these topology mappings being static topology mappings, we can have them dynamic, where each and every part of the or each and every component of this diagram will be showing the status of that particular component, whether it is red or green. And when we click on the component, it will be showing the relationship data, right? What are the infrastructure components related to that component, and what are the networks that are related to that component, right? So to have this dynamic diagram instead of having a topology mapping diagram, static topology mapping diagram, which would be possible with the AIOPS, and having the event correlation dashboards. When we have an event, we can have the event correlation dashboards where all the metrics related to that particular event and all the components related to that component to that event will be presented in a single pane, so that it will be easy for the ops guys to kind of jump on it, and also it will be a combination of it, like all the data related all the data that we collect from the AIOPS will be mapped in that single pane. So that is one approach through which we can solve this problem of event correlation. And the next is operational noise or false alarms. So we can most of the times it will be let's say due to one common cause there will be 10 alerts, right? So we can handle this situations by clustering all these common events and sending it as a single alert. So that is one approach, and that can be done using AIOPS. And dynamic thresholds is something, let's say if it is a certain known issue and it is not causing any issue to the system, then we can dynamically suppress the thresholds to suppress the alerts. So that can be done with the AIOPS. And to reduce, to overcome the challenge of collaboration between the teams, we can effectively utilize all this data and put all this data in a unified UI, where the event tracking or managing the event or incident and engaging the different teams and integrating between the tools, everything can be done from a single UI, so that all the data which is required by the ops to triage an event or to work on an event or incident can be represented from a single unified UI. To overcome the reactive, the proactive nature, to overcome the reactive nature and to become proactive, we can have certain features like the predictive incident assignment, where based on the history of the events, we can analyze the history of events and we can predictively assign the incident to a certain team or a certain person. And we can have the predictive analytics dashboards, where it talks about the system performance and different metrics, and predictive capacity management, where the capacity can be managed well before it is required to upgrade or downgrade. And the repetitive and redundant tasks can be handled with automated runbooks. I mean, right now we have we are using Chef and Ansible and for provisioning automation, and we have Terraform for infrastructure automation, and several other tools for handling the automated tasks in terms of infrastructure and all. But mapping it to the issue and automatically running them when a certain issue occurs, and intelligently identifying that running this runbook could be the solution for this particular issue, is something that we can do with the help of AIOPS. And for the continuous improvement, it's when we have the dashboards which represent the performance of the system, and on a timeline how the performance of the system is upgrading or downgrading, and how the resource utilization is being upgraded or downgraded. If we have the dashboard view of it, it will be easy and it will be a compulsion for us to kind of go for the continuous improvement of the system. And that's how we enable the continuous improvement by visualizing and presenting all this data using the AIOPS. The amount of the data that we collect from the AIOPS will be helpful in presenting these dashboards in a meaningful manner. So these are some of the challenges and the solutions that can be provided from the AIOPS. And how do we measure the success of an AIOPS implementation is we have certain KPIs to measure the success of an AIOPS solution, where we have mean time metrics. If there is an increase in the mean time, identify mean time to identify and mean time to investigate and mean time to resolve. It shows the state of the system is becoming better, and it represents the the implementation is getting success. And obviously there are other metrics like the system uptime and the predictability of the system, and the continuous enabling the continuous improvement and optimization of the resources. We can have metrics from the system to derive this KPIs and work for the target KPIs before implementing an AIOPS solution. And once we implement the AIOPS solution, we have this metrics, and the increase in the metrics or the betterment of this metrics represents the success of an AIOPS solution. Before we talk about the AIOPS architecture, I'll quickly talk about the AIOPS fundamentals. Again, this is represented from the Gartner's website, which pretty much encapsulates the AIOPS process into three major categories like observe, engage, and act. And all this is done on top of the ITOps data using the machine learning models or the analysis. So the observe part of it talks about how we collect the data, and how we process the data, and how we analyze the data, and how we visualize the data. So using the machine learning model, how we analyze the data which is collected from the monitoring tools, and how we represent it in the dashboards. It's pretty much the observe part of it. And the engage part of it talks about the different workflows involved in in this process, and obviously the workflows and the approval mechanism, and the integration with different tools with the chat tools integration, the incident management tools integration, and the knowledge ingestion. So engagement also talks about engaging different teams in this process, whether it is the SRE or the DevOps teams, engaging the teams into this process and ingesting the knowledge from these teams into the AIOPS process. Talks about engage part covers these things, and the act part is talks about the automated workflows or automated runbooks, and reporting on top of the data that we collect and analyze. So these are the fundamentals of the AIOPS and how these are mapped into the different aspects of the process. And into the architecture part, before going to the architecture part, I'll also quickly cover about what are the different kinds of data. These I've tried to represent a sample subset of the kind of data that can be collected from a system. So we have system metrics, we have application metrics, we have database metrics, and we have network metrics. So in the metrics category, we have these are some of the metrics that I've represented. The more data that we have, the more analysis can be done on top of the data. This is a sample subset, as I mentioned. So in the system metrics, we can have Linux or Windows system level metrics, like what is the CPU usage, what are the network usage, what is the file system usage. And in the application metrics, we can have application performance metrics, like what are the request response times, and what are the request response rates, and the error rates, and the application memory usage, and the garbage collection usage of the application, if it is a Java application. And the database metrics talks about the database specific details, like how many queries are being processed, and what is the disk read writes, and what are the tables that are being used, how many tables are used, how many collections are used, specific to the database. And in the network, we have the network specific metrics, like how many TCP connections are there, how many dropped connections are there, how many delayed acknowledgements are there, the network level statistics. And in the logs category, again, we can have the application logs, we have the database logs, and we have the system logs. And we can have much more logs, but I've just tried to present these three logs here. And the main parameters that can be fetched from these logs is the timestamp and the component for which the logs are generated, and the log message, and any errors or exceptions in the logs. And in the service discovery data, we can have the service status primarily, and we can have the service catalog, where we have a catalog of all the services that are there in that particular system or in that particular environment, and the dynamic state of the service at that point of time, and the mapping between the different services, the dependencies mapping between the different services, and the infrastructure component to the service mapping, what infrastructure components are related to the service. So this kind of relationship mapping data and the service status data can come under the service discovery category. And environment discovery category pretty much talks about the different components in an environment, infrastructure components in an environment, and the status of these infrastructure components. Usually the service discovery and the environment discovery will be done from a single tool like console, where we can do the service discovery of the application components and the infrastructure components. And the inventory data, which talks about what environments are deployed, what host names, what node IPs, what schools, and what network CIDs, all this stuff. And in the incident and config data, we have the image versions, the package versions, the release versions, the component softwares, and the certificates. All the configuration management data will be part of the the config data. And usually we fetch this data from a configuration management tool or CMDB. And finally, we have incident data, which talks about the incident status, the incident description, assigning, and the component team, or fixed by if it is already fixed, and resolution if it is already fixed, and that kind of data. So these are the sample subset of data that the sample subset of data that can be collected from a system or from an environment, from an application environment. Now we are going to talk like how this data will be utilized in the AIOPS and how it will be analyzed, the whole flow of it. So the architecture is represented in 4 layers over here: the data collection layer, and the data processing, and the data analysis, and the data visualization. So in the data collection layer, we have the application environment, and we have different tools monitoring this data in the application environment, from the application environment, like the monitoring tools, log monitoring tools, and we have ITSM tools, incident management tools, and service discovery tools, the inventory management tools, and the configuration management tools. So usually these tools have either endpoints or agents or custom scripts or out-of-the-box integrations, so that they can fetch the data from the application environments. And for our model to fetch the data from these monitoring things, we can use the API calls or command line integrations, so that we fetch the data from these tools. Usually the data will be the metrics, logs, and service status, inventory alerts, blah blah blah, whatever we have discussed before this slide. So these are the kind of data that we'll be collecting from the application environment through these tools using the API calls, and the data will be processed. The data will be sent to the processing layer. The data processing layer, we collect all these metrics, and the metrics will be the metrics data, and the monitor data will be parsed and contextualized. So each and every data will be passed based on the kind of the data. For metrics, it will be certain values, the certain key values that will be passed. For the logs, it will be certain key values that will be passed. In a similar way, for the kind of data that we retrieve from the system, the respective data key values will be passed, and we store this data. Once we pass this data, we parse and will label this data accordingly, and will store this data. So usually before storing the data, we normalize the data. So let's say in case of Prometheus, when we fetch the Prometheus metrics, usually it will be in a JSON format. When we use the Prometheus query language and we fetch the data, it will be in this format. So we normalize this data in, so that the machine learning model will understand it. So we will put it in a row format, like where the time at which the metric is picked, it will be in it will be the primary key for that one, and all the other data will be represented in the row. Okay. So there will be the certain duplicates, like in this case, if you see, this is represented in time series manner, where in the 5th second the data is collected, and in the 15th second the data is collected, and in the 20th second. So in the 5-second interval the data is collected, and in the 5th second the data in environment dev for service 1, which have 2 nodes, node 1 and node 2. So for node 1, the here we are trying to collect the file system size. So the file system used is 15%, and the available is 30. So 15 GB, and the available is 30 GB. The usage is 50. So similarly, service 1, node 1, service 1, node 2, service 2, node 2. So it will be represented in this format, so that it will be easy for the machine learning model to parse this data and run its ML on top of the data. And usually store this data in the event database, where at that particular point of time, if an alert is occurred or an event is occurred in a system, all the data at that point of time, whether it's in some time frame, like a 2 hours time frame, all the data will be stored in the event database, and all the configuration will be stored in the configuration management database. So the configuration, the data that comes under the configuration category will be, the topology mappings, the configuration management data, like the versions, packages, and the inventory data will be stored in the configuration management. All the other data, like the metrics, logs, the alerts, and the incidents, will be stored in the event database. And the data will be fetched from the data analysis layer from there. So in the data analysis layer, we have two kinds of data. One is the dynamic data, and other is the historic data. So dynamic data is when there is an event occurred in a system and it triggers the dynamic data. And for the general machine learning analysis and machine learning training, we have historic data. So when the dynamic data is triggered, the ML model fetches the dynamic data, and for either for the dynamic data or the historic data, it applies certain machine learning algorithms. So I tried to represent these 5 machine learning algorithms over here. Each have their own purpose. Like the logistic regression will be used for correlating between the data, and linear regression will be used for the anomaly detection, and NLP will be used for trying to correlate between the text, and time series forecasting and distribution statistics will be used for the predictions of the data. So we use these algorithms, and on top of the dynamic data, we'll be performing certain actions like detecting the anomalies in the metrics, and detecting the anomalies in the logs, and correlating between different events in the system, and aggregation of different events in the system, and detecting the pattern for an incident. So this will be done on top of the dynamic data, and on top of the historic data, the pattern analysis will be done, and predictions will be done, and reporting analytics will be done, and the machine learning model training, which will be a scheduled process, so that the ML databases need to be refined and trained. So once the data is analyzed, the analyzed data will be stored into the databases. The reporting database can be used for the visualization, and ML training database will be further used for the machine learning model. And based on the analyzed data, if the anomalies are detected, or the correlation is detected, the correlated data or the detected pattern will be presented in alerts, or based on the outcome, the automated actions can be done, like running automated runbooks, running the automated health checks, or auto recovery or auto healing. And in the final data visualization, we collect all the data from all these databases, from the event database, the CMDB database, the reporting database, and the training database. And we have a common user interface, which will have all these dashboards, which will be representing the data in the dashboard. So the service status data, the topology mapping data, the event correlation dashboards, the incident management dashboards, and the embedded dashboard, the performance reports, the prediction graphs, resource optimization dashboards, ML feedback dashboards. All will be, and the custom rule ingestion dashboards, where we provide the SRE the provision to kind of define custom rules. Let's say if this issue happened, this resolution need to be implemented. So those kind of dashboards can also be provided from this user interface. So I'll cover the workflows a little bit in the preceding slides, which will wrap, and make us understand more about how these 4 layers are utilized in action. And in this slide, I try to represent an AIOPS solution using the open source tools, and this can be used as a reference architecture for it. Yeah. So here I try to represent a Kubernetes application, which is a simple application, which is a 3-tier application, where we have load balancer or a web server, and application the database. And the metrics of these nodes will be collected using a Prometheus, and the visualization of the metrics will be done using a Grafana. And for the log monitoring and the application performance monitoring and the service discovery monitoring, we'll be using the ELK stack. So uptime is one of the component in ELK, which will be used for the service discovery, and APM will be used for application performance monitoring metrics like the request response rates and the error rates and the latency, all those figures. And we'll be having Beats agents to collect all the data from each and every component, and the data will be collected into this agents, and it will be before sending it to the log stash, we'll have another log stash where we do the relabeling part of it, and from there we'll be sending this data to the Kafka. And from Kafka, we have one flow where it will be sent to the Logstash, Elasticsearch, and Kibana, where the dashboards, the data will be visualized from the Kibana dashboards. And we have another flow where the data collected from the Prometheus, the monitoring data that is collected from the Prometheus will be sent to the Kafka. And from Kafka, the logs that are collected from the Logstash and the metrics that are collected from the Prometheus, and apart from logs, we also collect the application performance monitoring data and the service discovery data and send it to the machine learning model. So for handling the streaming data, usually it will be a time series kind of data where we have the data for each and every second. So to handle this huge volumes of data, we need to have a big data pipeline kind of thing to handle these things. So we use the Spark streaming for streaming this data, and we have our machine learning model as a backend jobs in the Spark, and we do the processing and analysis using these jobs, and we also collect the incident management data and the configuration management data directly into this ML model. And based on the analysis from the ML model, there can be 3 actions to have the automated actions and to send alerts or to store this analysis into the database. For automated actions, usually we can have runbooks defined in the Ansible, and we have Terraform code where we can trigger the automated actions like provisioning, something in Terraform, or recreating an infra component using Terraform, or running some software provisioning, or updating a version of a software, or reinstalling a version of a software using Ansible. Such automated actions can be done using Ansible and Terraform. And for the alert part of it, we'll be sending the alerts to the chat tools like Slack or Teams. And if there is a chat ops integration, we can again have a flow from where we can accept the inputs from the chat ops, and again the Ansible or Terraform scripts will be triggered based on the chat ops commands. And this is about this flow. And for the visualization part of it, we can have a unified UI where we collect the data from the database that is populated by the analysis data, and we can have the embedded dashboards from Kibana, and we can have the embedded dashboards from Grafana. And like the dashboards that we have represented in the previous slides, we can have all these dashboards in a single unified UI. And the service, the SRE person can monitor these unified UI and the chat ops tools to effectively monitor the system. So to give a better understanding about how how this works in the real time, I've defined some of the use cases. So these are some of the use cases that can be implemented using AIOPS. I mean, there are many use cases, and usually that will be specific to the environment that we're working. So, but these are some of the use cases that can be commonly handled in an enterprise systems. So we can have dynamic thresholds for CPU hikes is one use case where usually at some point of time, if the CPU hike is going to 90%, and again immediately it will come back to normal. But usually we'll have an alert triggered for such scenarios. But somebody usually from SRE will check that alert and see, okay, this is an usual pattern and it's fine. So to kind of resolve that alert. So the SRE person will be resolving that alert, but this is all time taking. A person need to acknowledge the event alert and then verify the authenticity of that known issue and then close the alert, right? So to overcome this, we have the dynamic thresholds where the machine learning model will be detecting whether this is a common pattern or not. And if it is a common pattern, it will try to suppress the alert and send the alert, send the notification to the SRE person to verify that. So that is the dynamic threshold CPU hikes use case. And prediction alerts is where we have a consistent increase in the metrics of a particular metric type, the system will predict the alerts which will the threshold alerts which will be triggered in the near future. Like disk full is one example. Let's say in a timely manner, if the disk is growing like 10% every day, and it is more likely that in like 10 days or in a week it will go to 100%. If it is 30% and if it is growing 10% daily, then it is more likely that it will go to 100%. So that predictions usually are simple in machine learning, but it can be implemented using AIOPS. And automated incident management, where usually this happens in most of the organizations, where we have the service desk teams which handle the first level of triaging the incidents and assigning to the respective teams. And from there, usually it will be routed to the different teams based on the action that is required for resolving that incident. But it's a time-taking process, and it increases the mean time to acknowledge the event. And somebody to work on that event, it takes more time. And sometimes it will be a recurring process where it will be switched between the different teams to get it assigned to the right person. So instead of that process, we have the machine learning model which will analyze through the incidents in the history, and it will try to match the summary and the description with the events in the history, and try to automatically assign the incident to the right person or a right team. And event aggregation is where we have incidents or alerts which are triggered due to one common reason, or which are related, that can be aggregated into a single alert. Instead of having multiple alerts, they can be aggregated into a single alert and send it to the user. So this decreases the operational noise, as we discussed earlier. So one of the common use cases is, let's say, if there is a DB DB outage, most of the components in the system will be using the same database. So if there is a DB outage, then it is likely that all the components which are fetching the data from this database will be failed, right? So usually we have an alert for each and every component getting triggered due to the component level SLAs. And so usually people will be tracking and resolving or working on these events separately. So instead of having them separately, we can aggregate all these things into single event and then present it to the SRE as an alert or from the event aggregation dashboards. And the last three talks about doing a preliminary RCA for certain events. Whether they are the threshold alerts or SLA KPI threshold alerts, like for the application latency or the log errors. So doing an RCA on top of the data that is being collected by the AIOPS, and trying to find the correlation between the anomalies in the data, and presenting it as an RCA to the user, either through the dashboards or through the alerts. So these are some of the use cases that I try to represent over here. And the next 4 slides, I'll quickly talk about, out of these use cases, I'm going to talk about 4 use cases and the workflow behind these use cases, how they can be implemented. So the first one is the dynamic threshold workflow, where the trigger is an alert. When there is an alert in a system, the processing jobs will be triggered, and the processing jobs will be fetching the alert specific data, like the date, time, the alert summary, the description, environment, and the component, and the severity. And if there are any custom labels, it will fetch all the data. And the processing jobs will try to fetch the metrics for that particular component at certain time frame. Like it can be 1 hour or 2 hour time frame based on the maturity of the model. We can tweak the time frame, but it will be like 2 hour or 1 hour or 3 hours time frame. We fetch the metrics from the data collection layer, from the monitoring tools. We'll be fetching the data. Usually it will be a query with the date and time and the component name, and the metrics will be fetched, and these metrics along with that event the data related and stored in the event database. And from the event database, the data will be fetched into the ML model. The ML model will be checking for the matching matrix pattern. So usually, if it is, it will treat that 1 hour data as a pattern, and it will try to find if there are any matching patterns from the history, and it'll fetch the data from the ML training database. I'll talk about like how this ML training database is being populated. But for now it will try to check the matching pattern and from the ML database, and if it finds the pattern, it will if it finds, there are two cases: if it finds the pattern or if it does not found the pattern. If it finds the pattern, it will check like how many patterns are matched. So we can again tweak this based on the ML model maturity. If, like, let's say initially we can have the matched patterns less, and eventually we can have the matched patterns more, so that we increase the precision of the ML model. And if it is like the n, if the value of n is like 5 over here, if the number of patterns that are there in the history, they're matching this event pattern, if it is greater than 5, then it will resolve the alert. Once the model is mature enough, we can have the workflow to resolve the alert, or we can have, instead we can send a suggestion to the SRE through an alert, saying that okay, looks like there are 5 patterns in the history for this alert, which says like this usage is temporary, this hike is temporary. So maybe you can resolve this one. The SRE can take a call on whether resolving this one, resolving the alert or not. If the matching pattern is less than certain count, it will just add the pattern data to the ML training database, so that it will be useful in the next iteration. So that's how the ML training database is being populated. So this is the data for this is the flow for the dynamic thresholds, and the next one is automated incident management. So the trigger for automated incident management is obviously the incident, and when an incident occurs, the processing jobs in the background will get triggered, and the date and time and the incident details like the summary, description, and the state of the incident will be passed to the processing jobs, and the processing jobs will be sending this data to the event database. And from the event database, the ML model will be fetching the incident specific data. So main parameter will be incident state. So if the incident state is created or updated or resolved, it will check for these 3 states. And if it is created, I mean, we can increase the options based on the amount of use cases that we have. And if it is created, it will check for the matching incidents from the history. Again, the matching instance will be checked from the ML training database. So how it checks is it is basically treat the summary text from the summary and the description, and it will process using an NLP, and it will try to match the text in the history of the events. So if the percentage of the text from the summary or from the description matches certain percentage, then it will primarily, again, we can have less percentage initially, and then once the model is matured, we can increase the precision or the match percentage of this summary and the description text. If the match is less than certain percentage, it will just add the incident data to the ML training database, and it will add all the correlated details into the ML training database. If it is more than a certain percentage, it will automatically assign the incident to the person which is there in the history of the events, and it will assign the incident to that person, and then it will update the comments with the suggested resolution. It will try to parse the resolution from the history of events, and it will update the suggested resolution. And it will update the incident management tools using API integration. It will update the incident management tool with this data. And if the incident is updated, it will do nothing, and it will just update the ML training database with the updated incident data. so that it will be used for the next iteration. And if the incident is resolved, it will try to fetch the resolution and the resolver data from the incident management tool, and it will pass like the parameters like the incident ID, and it will fetch the incident resolution and the resolver. Once it gets the incident resolution and the resolver, it adds the data to the ML training database. So that's how the the ML training database maintains the history of the incidents. And the next use case workflow is for the event aggregation, where the trigger for this one will be the, when there are multiple alerts in a system at certain point of time. It will be in 1 2 hour time frame, or maybe 30 minutes time frame if there are multiple alerts in the system. Again, the alert specific data will be sent to the processing jobs, and the processing jobs will be pushing all this data to the event database, and from there the ML model will be fetching the alert description and the alert summary majorly, and it will try to match the alert summary or alert description text with the alerts. So if it finds the both these alerts has the summary or the description matching, then it will try to check how much of the summary or the description is matched. Like most of the cases, like let's say if the summary is matching like more than 95%, that could say that they are related to a certain component, or maybe they came from a same source, right? So once it founds the match is more than certain percentage, if that is the case, if it is less than certain percentage, it will just ignore and send the data, add the data, the event data, the metrics data, and everything to the ML training database. If it is greater than, then it will try to kind of cluster the related alerts and send it as a single alert to the SRE. And same goes for alert description. To increase the precision of the model, we can combine both. We can only trigger the alerts when both the summary and the description is matching more than 95%. Usually this is just a text matching, and once the matching is more than and certain percentage, we can cluster the alerts. But if it is less than, we can just ignore it and send the data to the ML training database. And another use case is instead of matching the text, we can also try to apply some intelligence over here by matching if there is any common dependency for both these components for which the alert is triggered, and if the common dependency is failed, the system, the ML model will check for the topology mapping for that one, and it will fetch what are the related components for both these components. So let's say if a database is related to both these components, and if the database is down at that point of time, so it means that both these alerts are due to the same reason, right? So it will fetch the using the topology data. It will fetch the common dependencies for both these components, and check if the common dependency is failure. If there is any failure with the common dependency. If there is a failure with the common dependency, it will consolidate this information and send it as a clustered alert. If it is not there, it will just add the data to the ML training database. Yeah. So these are some of the use cases.
I will interrupt you here, just sorry, because we only 5 minutes left, and we have a few questions in our Q&A section. Sorry, just like seems that it's a very interesting and terrible topic, and this topic, I mean, like it's need more than 1 hour to discuss. Anyway, I don't think that we will cover all of the questions which we currently have in our Q&A section. But anyway, just first of all, please remember that you should select the most interesting question from your side. And guys, if you still have so many questions, I will post to our Q&A section where you can, continue conversation with Vamsi Krishna, ask and share your experience and maybe ask your questions. So, most likely the question which have more likes. What's the fundamentals workbooks which feel the basic of AI, artificial intelligence? What's your, I think, recommend to start to, understand what is totally AI and understand the basics of this topic?
Okay, so I mean, as far as one second, I'm trying to. I'm listening the echo of my voice. Okay, now it's fine. Yeah. So it is that the information is spread across different sources. Usually, for getting the information, I have referred to the different blocks from different monitoring tools. So usually, AIOPS implementation are either done from the monitoring tools or in the market. Usually, it is done from the monitoring tools or the incident management tools. Something like a ServiceNow has its own AIOPS implementations, and the monitoring tools like
So I think
Splunk
like
and
question not
AppDynamics.
related to some tools, sorry, Ramsey Krishna. Maybe I mean like the question related totally AI, artificial intelligence, not like some specific tools which realize this approach. I mean, maybe you can recommend some basic fundamental book which related AI in general.
Okay, so I'm not an to be specific, I'm a DevOps guy basically. So I'm not an expert in AIOps in machine learning, but I mean what I have referred is with the different implementations we have like for Resolve we have the documentation where it talks about what machine learning algorithms it has used to implement the AIOps in that tool. And so I've tried to refer these things and then kind of collate all this data and then put it in this form. So that's what I referred. Yeah, I mean there are a few books I have referred, but they are again from the monitoring tools. But I'll probably you can contact me for you can send me an email. I'll send across the references that I've used.
Yeah, guys, I see that we still have some questions which just came to us. So for example, Sakas also currently just post his question. Guys, you can, I think, continue the conversation on community that platform. I think the last question which we will be able to cover it's also, like for me, it's pretty interesting. Are you executing tasks automatically based on the events? For example, disk full, delete files, or extend disk? Or everything is sent to operations teams?
Right, good question. So basically that depends upon the precision of the ML model. So initially we can have the suggestion based alerts, and once we have a good we can have the feedback mechanism for the ML model, and once we have the feedback ratings which are more than 95% for the ML model, then we can have the automated events automatically triggered once there is an event. That will be eventually done once the ML model precision is more than 95%.
I get. I think the last question. Sorry, guys, just like we have to finish. It's just like in 1 or 2 minutes. What's the most surprised event declaration that you have detected, and how many false alerts did you have?
So most most false alarms could be with respect to the disk usage. Let's say in one case we have Cassandra. Let's say we have compactions which are going on in Cassandra. So during the compactions in the Cassandra, it will take most of the disk space. It needs to create the SS tables dynamically, and it takes most of the disk space. During the time, the disk space will exponentially go to the go high. So at that point of time, usually we get the disk space alerts, but usually after some time, once the compaction process is completed, it will go back to normal. So usually we have the we can have the dynamic thresholds implemented in that particular scenario. That is one example that I can think of. And what is the other question?
I think that like that's it for today. Like just like in 4 minutes we'll start the next sessions, guys. So sorry, just like seems that we need a little bit more time. Vamsi Krishna, if you do not mind, I will share with you all the other questions, and if you will be able to answer on our community that platform, it will be very great. Thank you very much for your very interesting speech, and see you guys on next our talk in 4 minutes.
Okay, thanks everybody for for listening to the topic. Thank you. I'll try to reply to the comments offline. Thank you.
Thank you.